Conversely, when friction is high, for example, during braking of a Formula One racing car, sliding of the frictional surfaces is more difficult and they become hot and worn. When unlubricated surfaces move, the asperities deform elastically or plastically and can weld together if load, speed conditions are sufficiently severe. The harder the surfaces are forced together, the greater the friction and wear. Graphite, molybdenum disulfide, or chemical coatings are used to prevent metallic contact when extreme conditions of operation preclude any possibility of utilising fluid lubricants. Liquid lubricants are used to reduce friction to low values when design features permit formation of an oil film of sufficient thickness. There are applications where, although the establishment of a sufficiently thick fluid film is not possible, suitable oil additives can be used. Lubrication may thus be conveniently classified into three categories. Boundary lubrication, in which a considerable degree of contact occurs between the mating surfaces. Mixed lubrication, where formation of a fluid film is partly established. Hydrodynamic or full fluid film lubrication, where the contact surfaces are completely separated by an oil film. The boundary conditions exist as movement commences from rest and friction between mating surfaces is high due to frequent metallic contact. The entire load is carried by lubricant film considerably thinner than the surface roughness. The friction is far lower than for unlubricated surfaces. Friction and wear are determined by the properties of the surface layers, that is, physically absorbed oil additives, chemically bound surface films, etc. The viscosity of the lubricant is of minor significance at boundary conditions. When metal surfaces slide over each other under boundary conditions, there will normally be some degree of metallic contact. This is transformed into heat, which gives rise to local flash temperatures. If loads are too high or speeds too low, dangerously high local temperatures will be obtained, causing the metal to melt at the asperities concerned. To avoid welding at the surfaces, metal transfer and subsequent seizure extreme pressure, or EP additives, are incorporated into certain types of lubricants, such as oils for heavily loaded turbine gears. These additives are activated by local high flash temperatures and react spontaneously with the metal surfaces, forming a chemically bound surface film. The adherent surface film, which has a lower shear strength than the underlying metal, reduces friction to an acceptable level and protects the metal substrate. EP additives vary in chemical composition and reactivity, but they are intended for use with ferrous metal surfaces and may cause corrosion of other metals. EP additives vary in chemical composition and reactivity, but they are intended for use with ferrous metal surfaces and may cause corrosion of other metals. As speed increases, there is progressively less contact and friction between the surfaces. This is the region of mixed lubrication, where the thickness of the lubricating film approximates to the roughness of the surface. Hydrodynamic lubrication is achieved when the relative speed of the surfaces is sufficiently high to form an oil film significantly thicker than the surface roughness, separating the two surfaces. The thickness of the film is proportional to the lubricant viscosity. Therefore, higher viscosity is required for heavy load, low speed, high temperature, or conditions involving shock loads or vibrations. Various formula and nomograms are available for calculating the lubricant viscosity requirements. EHL is a special form of hydrodynamic lubrication developed for heavily loaded rolling contacts, such as roller bearings and some gears. Lubricant is squeezed into the contact area and subjected to extremely high pressure. The very high pressure results in tremendously increased viscosity of the lubricant and thereby significantly improved load carrying capacity. The contacting surfaces are elastically deformed, thereby distributing the load over a far greater area. Let us summarise some of the topics. Lubrication reduces friction, wear and resulting power losses. It also transports heat produced by friction. Viscosity is the main criterion for fluid lubricants operating under hydrodynamic conditions. Lubricants are formulated with lubricity and anti-wear agents for applications where boundary conditions cannot be avoided. Active EP lubricants are required for extreme conditions of high load or low speed.